salesman. Former. Yeah, retired. Al Torfer's best retired salesman. So, good stuff. Hey, 3:30. Start on time. So, luckily we got a little bit of airflow for everybody here. I think Dave brought his fan in here to get us a little airflow. It was a little sticky yesterday, so we'll get her going. So, welcome everybody, Cat Talk. I'll kind of get you going. We're going to talk about electric drive bulldozers. So, we've been on electric drive dozers for quite a while now. Did that stop? 2009 was our first product in the field. So we'll talk about a little bit of the history of that, where it came from, and a little bit of everything there. So introduce myself. My name's Sam Meeker. I've been at CAT for 26 years. Product applications for most of my career. And what that is at Caterpillar is we work a lot with our dealers and our customers to help them place the right products in the right place. Make sure that we're getting the feedback from the customer to be able to improve the products appropriately. I like to translate. I like to say that my job is to translate redneck to nerd. So I talk with customers and figure out what they want, and then take it back to the engineers and tell them what they want, and then the same on the way back. So. I'm a tractor fanatic. I'm an old tractor fanatic. Absolutely love this place up here. This is an amazing museum and place that John has built. So it's been great to have a relationship with him and the crew up here at Monia Crew for all the years we've done it. So I do a little bit of farming on the side. I enjoy doing that. My family, 21-year-old kid, Blake, so he's about yay tall. Diesel technician, farmer, and nerd as well. He's going to get into the drone spraying business, so that'll be kind of fun. But we farm a little bit in western Illinois. We've got a little bit of yellow iron here and there. We do some light earth moving, some of our own waterways and dry dams and things like that. And then he's doing a little bit of contract work out there too. So if you need a driveway reconditioned and you're in western Illinois, let us know. We may even travel over to eastern Iowa. So travel time and mileage, you know what that is. So. Yeah, anyway, getting ready for a good harvest. We're looking forward to that. So, all right, I do have some fabulous prizes, and so we'll start with a quick trivia question. So, what company was the first to develop an electric drive track type tractor? Yeah, technically it's the 20th century. Yeah, technically it's 20th century. Yep. Yeah, no, you're not a German engineer. It was an American company that built that first, but I think you're thinking along the right lines. Any other guesses? Come on, there's fabulous prizes on the line here. What's that? Edison? No, but close. Any other guesses? John Deere. Who? Never heard of her. She sounds hideous. What was that? Holt. I can't give you a hat because you already have a hat, but you're right. I already gave Alex a hat too. So we're here. Give somebody a hat. Make them happy. We're just going to play catch back and forth. Dwayne, you got it, buddy. All right. 1917 Holt gasoline electric tank. Joint effort with General Electric. Kind of close to the Edison thing. You were close. Used a 90 horsepower Holt gas engine and an electric motor on each side. So one electric motor for each track. We call that wheel stations today for that electric technology. We call that wheel stations, so that's what that is. Not only first electric drive track, but the first American designed tank. So kind of an interesting little piece of trivia there. So beyond that, let's go ahead and get in and talk a little bit about some of the innovations that we've had at Caterpillar over the years. And I always kind of like to preface and start with this. I think it's a great slide. Obviously, 1904 was the first track layer or the first track type tractor to utilize tracks instead of wheels to get a little better traction on the ground, lower ground pressure, etc. 1919, the best 60, really kind of defining what a track type tractor looks like, acts like, feels like, balance, operation, things like that. 1925, of course, the merger of the company between Holt and Best to form Caterpillar Corporation. 31, first diesel, pretty exciting to get into diesels. 1945, we started making our own work tools. Previously, we'd worked with other manufacturers, LaPlante Choate, of course, Letourneau, to make those tools. And 1945 was some of the first work tools that were Caterpillar branded. I have a 45 D4, and we did a little bit of research on it. We think it's one of the first D4 blades that was ever made. It's got the little logo on it there, too. So kind of exciting. 1959, or 55, turbocharger, all right. Another little fun thing. What other technology came with the turbocharger that was novel for the time? Related to air. What's that? Wastegate? Nope, not yet. Related to air. Air cooler? Kind of. You're going to go with the hat. You're going to get the hat because you were GE, you were Edison, you were close before. So you're going to get the hat. But what we're going to do is we're going to talk about paper air filters. Because what were the air cleaners before that? Oil bath. What do you think turbocharger did to an oil bath air cleaner? Sucked all the oil out of it, right? And then all of a sudden it wasn't. So paper air cleaner is one of the fun things that came with that. 1959, power shift transmissions, still used today in a lot of tractors. 78, of course, high drive. That first D10 with that elevated sprocket. 1987, differential steering, so hydraulically powered differential steering. An amazing advancement as well. 2009, that was our first electric drive tractor, the first production electric drive tractor, the D7E. 2018 was our second generation of electric drive, the D6XE. At the same time that we introduced the D6XE, we took the D7E out of production. So first generation, second generation, we were ready to move on to the next gen. And then of course 24, our latest tractor we have out is the next gen D8. So just a little bit of history and some timeline there. Just a little bit about our product line. You may or may not know we did have some changes to nomenclature about 5 years ago. Much to some customers' chagrin, we do still get a little static about this. What's a D3? Is it a D5 or a D3? Well, used to be a D5K, and now it's a D3. So we changed the bottom half of that. The reason we changed that nomenclature, as we like to say, we needed to solve our D6 problem. We had 3 D6s, D6K, D6N, and D6T. So when you called up your local dealer and you said, send me out a D6, he either sent you out a 30,000-pound tractor, a 40,000-pound tractor, or a 50,000-pound tractor, and it was always the wrong one. So we decided we'd clean that up and change a little bit of that nomenclature to straighten that up a little bit. From the D6 and up, you'll notice that the numbers stayed the same. D5 and below, they changed. So today we're going to talk a little bit about the D7E, the predecessor, all right, that 2009 to 19 tractor, and we'll talk a little bit about the D6XE, which is in that D6 size class. So we'll jump right into it. So the D7E, pretty novel product at the time, 2009. This replaced the D7R, which was a high drive tractor, power shift. Kind of an old girl. It was time to do something with that. That one had skipped a couple of NPI cycles. So in 2009, it was pretty long in the tooth. So a very innovative and unique tractor. It was not only an electric drive tractor, but it also had some other innovations in here that were unique. Beltless engine, there was no belts on it. So all of the accessories were electrically powered. The cab tilted, something different for us as well. We tilted that off to the side to be able to get in and do any service work on that tractor. Modular air conditioning system, everything's back here. It's electrically powered. So no belts, no lines going back and forth between the engine. Everything's on the back of the cab. So the center post cab, had some people that always joked with us about that because that was unique for us as well too, right? They thought we went back to the green weenie days, the old Letourneaus. But one center post in the cab lined up with the exhaust and the lift cylinder gave you really, really good visibility out the side doors and windows. So it was also one of the first medium dozers that came out without an external ROPS. So there's no yellow ROPS bar here, right? So it was all internally ROPS cab. So internally supported cab for rollover protective system. So a lot of cool things on this tractor that were pretty unique. But of course the electric drive was the key thing to that. So we'll talk a little bit about the development of this. We really started with this electric drive back in the 90s. Yes, sir. What's that? We had no alternator. I mean, you talking about the generator? So there was no alternator, there was no accessory alternator on the side. It was just the generator. So generator on this tractor was 175 kW. Effectively 175 kW. Yep. So started really in the late 90s doing some work at the Proving Grounds, starting to play around with some of the different electric technology. There was also some other acquisitions that may have happened that time where we may have gotten a haul truck that had some electric drive technology in it, so we might have been able to sneak a little bit of that. We were also in the process of doing EMD, right? Electromotive diesel train engines. So we were able to steal a little bit of that technology as well too, and kind of put it all together and really brought that to production in 2009. We did a lot of different trials and testing. We tested against our friends. We tested against our enemies. We tested against the environment. So there's a water fording test, we called it, where we had to go through 40 inches of water. So another fun history or trivia question. How deep can you run a tractor in water before you're supposed to stop? How deep of water can you run a dozer in before you're supposed to stop? There's a definite answer. That's why there's a fabulous prize. Sir? Up to the fan. Exactly right. Why is that? Up to the fan. It'll tear your belts up. Yep, basically. Once that fan's used to running in air, right? Once that fan has to turn into propeller and start running in water, it basically puts too much load on the fan, tears your belts up, actually overheat the tractor if you run it too deep into the water. What we find most of the time is the rednecks will run them up into water until it starts coming in the cab. So the way that I've seen them operated, and you'll see a lot of these actually on beach reclamation jobs. D7E was a really popular tractor on beach reclamation. They'll back them into the ocean until the water hits the windows, put the blade down and push back up. And they'll push that sand back up onto the beach, get it all filtered and cleaned out, and then they'll make a nice beach again for them. So for an electric drive dozer to be able to run in 40 inches of water, I think is pretty interesting, right? You're not shorting anything out, not electrocuting any fish. So it's pretty cool feature. So a lot of benchmarking against our competitors as well too, to make sure that we had the right tractor and the right technology. So let's talk just a little bit about what the components are of the electric drive system. So 9.3 engines, so that would have been the old C9 or the 8.8 liter engine at that point in time. This was 2009, so this was Tier 3. The D7E actually went through 3 different engines. The Tier 3 engine, and then in 2011 we went to Tier 4 interim. And then in 2015, we went to Tier 4 final with DEF. So it did get to go through 3 different engines. But 9-liter engine, connected to that, directly connected, is that engine-powered AC generator. You're asking about that size. Basically, it's a 175 kW generator. But it's not the same generator you have in the county fair that runs the carnival rides, right? This is a fully sealed, electrically, or water-cooled generator. The whole system's fully sealed, water cooled. So there's no air that gets used to cool any of the electric components. It's all water cooled, fully sealed. So that generator creates the electricity, goes through these specially designed cables back into what we call the inverter. So the inverter is a series of power electronics, capacitors in there, a couple of big computers, and what it does is it converts the electricity from alternating current to DC, back to AC again, before we send it down into the motor. So why do we do that? The process of converting it AC to DC to AC actually smooths that power out, and it helps us to get a nice consistent power flow into the motor, so we have a lot of control over that motor and what power we're putting to the ground. So, of course, when that power goes in, it goes into what we call the propulsion module, and that's where the electric motor is, okay? I'm going to say electric motor because there's actually 2 motors in there, but they act as one. So what we found with the D7E was that by having 2 motors, we were able to control the inertia that we have with one big motor. So if you have one big motor, it takes a lot of energy to spin it up and get it up to speed. It takes a lot of energy to slow it down. All right? And what does a dozer do in a dozing cycle? It reverses direction about every 60 seconds. So we couldn't have that amount of inertia loss with one big motor, so we went to 2 smaller motors. Worked out really, really well on the D7E. So, and then of course, power out to the final drives. This other component in here, accessory power converter, This was a unit that we had that basically it did all the ground fault detection, so it was kind of the smarts of the system to be able to detect ground fault and make sure it was safe. It also converted some of that electricity over to run the electrically powered water pump and the electrically powered air conditioner compressor, and it also charged the batteries back up. So that's the alternator, quote unquote. All right? We had no alternator on it. So pretty slick. Just a component view of that. So the old D7R engine, torque converter, transmission into the bevel gear case where we split that power up, differential steering into left and right. D7E, similar, engine, generator, inverter, motor, right? Differential steering to split the power up left and right off to the tracks to make the tractor go. So, talk just a little bit about each one of these. So 9.3 liter, 235 horsepower. It's a great engine for us. Tier 3, like I said, then we went to Tier 4, interim, Tier 4 final over the years. Pretty good power plant for us in general. So generator directly connected to the engine, bolted right up there, rubber coupling in between, so we did have a little bit of power spike control there. Generated all the electricity. As I mentioned, that's liquid cooled, right? So it's cooled by both engine water, and it's also cooled a little bit with some of the powertrain oil because we lubricate the bearings with powertrain oil, do a little bit of cooling with PTO. Most of it is done with the engine water. So these are military-grade cables. I'll show you a diagram in a minute of how they're designed, but very, very tough and durable cables. And we have had really, really good performance out of these cables over the years. So very, very durable. That power inverter, again, converting that alternating current to DC back to AC again. Dave Talon did a really cool thing. He designed a hat that had AC, DC, AC in the AC, DC logo. We thought it was super cool. We were going to make all kinds of them. And then we went to the Dr. No of Caterpillar, which is, Greg, who is that? Brand. And they said, no, we cannot steal AC/DC's logo to make really cool hats. So that was that. So propulsion module had those two AC motors in there, and then it also had the input for the differential steering, hydraulically differential steering, which I'll explain. I'll show you a diagram for that in a minute. These components were fairly easy to remove and rebuild if you needed to. That was always part of our design, was if you wanted to take those components out and do a rebuild, they were pretty easy to do. So the problem. Final drives, double reduction final drives, spur gears on the inside, planetaries on the outside. A pretty typical final drive for a low drive tractor. So, and then that APC, powering all the accessory systems, charging the batteries back up, and providing the power for the water pump as well as the air conditioner compressor. So, fully sealed, liquid cooled. That was probably one of the most novel things about this electric drive system, because most of the other electric drive vehicles out there, whether it be trucks, locomotives, they were air cooled, and so the fact that we were liquid cooled was pretty unique and pretty neat. So, safety was a big thing on this tractor as well too. So one of the things we had to do was we had to make it to where it was safe for folks to work on the tractor, technicians to go out and work on the tractor. So what we did was we said, all right, we're going to go ahead and we're going to design a system that actively burns off the energy when you turn the key off. So anytime the engine's running, it's making electricity, and there's 715 volts in the system, all right, on the hazardous voltage system. When you turn the key off, there's still 715 in those capacitors, but it has to burn them down. So with the D7E, what we would do is we would use the capacitors, cycle them on and off, charge and discharge the capacitors, but we would also spin the water pump. So we would spin that electrically powered water pump, and within about 10 seconds, it took all of that energy out of the system, took it down to zero. We had a light inside the disconnect compartment so that we would let service folks know that we were out of energy and all the energy was out of the system. If they needed to do any troubleshooting, they could go ahead, start pulling covers off, and do some troubleshooting there. So pretty unique setup there. Made it very safe to work on. I like to say we made it safer than hydraulics, because hydraulics does keep energy in the system, and if you've ever taken a hydraulic fitting off, you quickly figure that out as it expels that energy. So here we actively burn that energy off to get it out of the system so that it's nice and safe for you. One of the other things we learned with the electric drive system was that we can extend some of the service intervals. Okay, so in particular, powertrain oil, and powertrain oil filter. So powertrain oil in a traditional tractor, and a traditional power shift tractor, it's going to do three things. It's going to clean the clutches, right? The discs and the clutches and the plates. It's going to cool, and it's going to lubricate. Those are the three things that powertrain oil does: clean, cool, and lubricate. By having no clutches in a transmission, no transmission on it, just an electric motor, we've taken the cleaning component out. All right? So now all it's doing is cooling and lubricating. So that means that we can make that oil and the filter last significantly longer than it did before, having lower cost for the customer and longer intervals, which helps to make that service a little bit easier. So that was kind of a cool thing with that as well. A little bit about the electricity. Everybody's always asking about this, right? So what voltage do you run? So generator, 480 volts AC, variable frequency drive. Energy goes back into that inverter, 480 to 650, converted back to 480, all right? And we would shoot a little bit of that energy out to that auxiliary power converter, but then everything went down, that was going to drive, went to 480 VAC variable. Some of the other systems in here that were unique, the electrically powered components. So instead of having our goal was beltless engine. We thought, all right, it'd be cool to have a beltless engine, so you don't have to replace that fan belt anymore. Of course, the fan was all hydraulically powered, just like they are today. But we had to deal with the water pump, and we had to deal with the AC compressor. So went with an electric water pump, so electrically driven water pump. Pretty unique there. And then also the AC compressor as well. So electrically driven AC compressors, which you see a lot in hybrid cars today, electric cars today. They all have electric AC compressors. So similar technology. We talked a little bit about those cables and connectors. A couple of comments on that. So ground fault detection is the system that we use on our electric drive machines. It's not exactly like your GFCI because of the power spikes that you get with basically a mobile piece of machinery. So what we do is we do significant ground fault detection, and we monitor the ground. We basically monitor system ground within the high voltage components versus frame ground. Because we don't ground to frame for the hazardous voltage systems. We ground internally between the generator, the inverter, and the motor. Those are all bonded and grounded together. So none of that energy is supposed to leak out of that system. So we monitor between tractor frame ground and the bonded components to determine if there's ground fault. And that's what that ground fault detection is. The other specific thing, which is pretty cool, are these orange cables. Thought those were pretty neat. A significant amount of armor and sheathing on the outside of them, right? Including a ground strap that runs in the sheathing here. So we basically ground the outside of the cable. So Nathan, if you were to take an axe at this thing and start whacking away at that cable, by the time you hit the sheath on the outside, before you got anywhere near any of the hot components, it would have ground fault detection and it would shut the system off. So pretty neat, and those have been very, very good for us in terms of the durability of those cables. Been super happy with that. So a couple other things that were unique. Cooling system, right? So we needed to, as I mentioned, we liquid cool those electric components. All right. Oh, one more fun trivia question. Caterpillar has liquid cooled other computers on machines before. Can you think of another computer on a machine that we liquid cool? What's that? Engine controller, exactly. Yep. We use fuel, unlike C15, 3406, we use fuel to cool the ECM. That's pretty amazing. I think that's cool. So, no pun intended. So cooling our electric components is not something unique, but something we needed to do on this. The other unique thing about this, though, is what temperature does your engine water typically run? 180, 200, yeah, a couple hundred degrees, right? We don't have these components running that hot. They run about 125. All right, so we needed to have a completely separate cooling system to maintain that 125 versus the 200 in the main engine water. And so that's what we've got here is this separate circuit cooling system. So it's got its own radiator core. It's quite a bit smaller than the other one. Still single plane. It's all lined up in the radiator with the other ones. And it's going to cool the APC, the inverter, the generator, and then also a hydraulic oil cooler, I believe, down there. So here's just a quick picture of what that looks like. So we got that separate circuit radiator. It's using the same shunt tank, so it's the same top off, same fluid, pink juice, right? Separate circuit pump. It's going to pump that back. We're going to cool the coldest component first, which is going to be the auxiliary power converter. Then we're going to go through and hit the power inverter, back to the generator, down to the hydraulic oil cooler, and then back into the bottom of the tank to go through its cooling cycle. So we maintain that with the D6XE as well, too. We have a separate circuit cooling system on it as well. So powertrain lube was something that was unique as well, too. Obviously, we're going to use powertrain lube to do a couple of different things. One is we're going to go in and we're going to lubricate that center of the inverter, so the rotor, the motor and generator. We're lubricating the bearings on the rotor, and we're also going to go back and hit the motors as well, too. So we hit the bearings in the motors, and we also bathe the motors to cool them off as well. So the cooling is actually with powertrain oil on the D7E. So hydraulic system was something a little unique as well, too. This was the first time we had worked with what we call a now I've forgotten it. We put the valve all the way out front, all right? So instead of having that back underneath the cab of the tractor, we've got the hydraulic valves out front. They're all electro-hydraulic anyway, but we're able to put that valve out there real close to where it's being used, which helps improve response and controllability on the hydraulic system. So that was something a little unique as well. So we run the D7E, our first generation electric drive system from 2009 to 2019. When we were at the same time we were developing this next tractor, the D6XE. A couple of the things that changed for us and why we stopped the D7E was there was a significant change in technology between 2009 and this 2019. One of the key things that the D7E was what we called a permanent magnet system, so permanent magnet generator and motor. The new systems are called switched reluctance, so they're more of a three-phase, and they're able to change the amount of torque and power very actively in the motor and the generator to get just the right amount of power that we want. So it's pretty significantly changed. I would say the way that I like to refer to that, who's got Milwaukee tools, right? Or even DeWalt, right? Even you DeWalt guys, I don't say anything bad about you. Remember that old 12-volt that you had back in the mid-2000s? It was a 12-volt drill. It was this big. It had this monster battery on it, right? And now you can get a tiny little M12 drill that does more work with a tiny little battery. That's the difference in technology. So the old permanent magnet was the big ones. They were a little weaker. They took a lot more power. The new switch reluctance technology uses smaller motors, smaller generators, smaller batteries. They're more power dense. You get a lot more power out of a smaller system. Sir? Yep. Yep. There was always plenty of power with the electric. That was one of the things with the D7E. There was always plenty of power. That was really more in the traction control system. So we improved we call it the software traction control systems, where we're monitoring that power. So what happens is, right, you load your blade up, and an old tractor is going to bog down on you because it's got the torque converter in there, and so it's going to kind of bog down a little bit and reduce some of that torque. The electric drive doesn't bog down. So we improve those traction control systems so we really watch what that motor speed's doing, and before it gets a chance to break the tracks loose, that motor speed gets a little spike, we're able to get that controlled and back out of it again. So worked really well, though. But yeah, yep. So 2019 was when we came out with the D6XE. This was a whole new centerline tractor for us. So I call it a 35-year redesign. So we redesigned everything from the undercarriage, roller frames, tractor frames, cab, engine, transmission. It was a really, really big NPI for us, new product introduction. So a very, very big introduction for us. Lots of cool things in there. One of the key things, though, was this next generation, second generation electric drive system that we got with the D6XE. So There's kind of three pillars that of value that the D6XE and any electric drive system is on. One is on productivity, one is fuel efficiency, right? And then the other one is actually rebuildability. So we like to say that our tractors are built to be rebuilt, and I think that if you're here at a tractor show where you're looking at 75-year-old machines out there, you understand that philosophy about rebuilding machines and continuing to run them. So that's one of the key design criteria we have on our D6XE. So we improve fuel efficiency quite a bit. So we have a lot of customers now that we're burning 8, 9, 10 gallons an hour on their old D6R, D6T, and now they're down in the 4s. So pretty significant reduction in fuel. That's a big part of it. The powertrain rebuild cost, right? So we just did the calculation and said, all right, if we were going to rebuild at 10,000, we actually get more than that out of the powertrains of these, which is great. But we're able to save $10,000 on a rebuild cost, which is pretty significant as well, too. A lot less rotating parts, so we don't have all of those clutches and gears. We basically have the electric motors, so we're able to get all of the speed range that we need just with the electric motors without needing those clutches and gears. So improved steering force as well, too, which is pretty important on a dozer. You don't always go straight. Sometimes you got to take stuff around the corner, and so that steering force was quite an improvement as well. So 6XE, similar layout to the D7E, 9.3-liter engine, generator connected directly to it. But as I'd mentioned, this is smaller, more power dense, more powerful generator. And then we went with one motor in the powertrain rather than two. With the advance of the switch reluctance, we were able to go to one motor to get us all the power we needed rather than two. So that was pretty important. The inverter was improved quite a bit as well too. So next generation of inverter gave us a little bit better serviceability on that as well. So talk just a little bit about the rebuild. So the challenge with a power shift tractor is the beauty of a power shift tractor is you can rebuild it, right? Take it into your dealer, they can make you a brand new one, just like that. Most of the time, this happens between 10 and 12,000 hours. All right, they'll recondition the engine, recondition the transmission at the same time. With the XE drive, we want to see you do it before 15,000. We have a lot of customers that are between 11 and 13 that are doing it right now, and most of that is related to the engine. So you're taking your oil samples, you're watching that, and the engine's going to tell you when it's time to rebuild the engine. So that's our limiting factor on that is the engine. The rebuild of an electric drive system is basically 4 bearings and 2 seal kits. So we're replacing the bearings on the end of the rotor in the generator and the motor. So you got 2 rotors, one in the generator, one in the motor. You're basically putting new bearings on the end of that. We want to see that done before 15,000 hours. So that's typically when they would do it, is that engine recondition time. We designed these tractors basically for 2.5 engines, so roughly 40,000 hours. So frame life of a D6 is roughly 40,000 hours if you want to go that high with it. There are a lot of customers that are getting into that second life and being very happy with it. So talk just a little bit about steering. So if you haven't been around differential steering, it's a little difficult to get the concept. So a lot of these old tractors that are out here are clutch brake steering, right? Watch that guy with those 2 D9s pushed together there. He's basically pulling a clutch on one side. He's removing the power from one side and then pushing a brake to slow that one side down, and that's how he's able to do the steering. Well, 1987, right, mid-80s, we came out with differential steering, hydraulically powered differential steering. So what this does is this lets us keep all of the power going to both tracks. We just change the ratio as to which track it's going to. So when you apply a steering force to turn with the hydraulic differential steering, you're reducing the speed of one track and increasing the speed of the other. As opposed to clutch brake, where you're just taking the speed of one track down to 0 and not speeding up the outside track, okay? So here's how this happens inside of the steering case, the diff steer case in the back of that tractor. You've got the motor. This is the motor that's providing all of your propulsion power. So when I talk about generator, inverter, motor, that's what this motor is. Spins one direction, tractor goes forward. Spins the other direction, tractor goes backwards. So that's providing power into this diff steer case where there's 3 sets of planetary gears. So here's one planetary, there's the second, there's the third. If anybody went on the tour with MTS, you got to see a planetary sitting in the final assembly shed. They had a planetary out, and you could look down in there and see the gears of a planetary. So when that motor spins, it's turning the planet carrier here, which is translating that into that center axle shaft, taking the power out to each side, left track, right track. All right? As long as you don't have any input from the steering motor, when you turn this planet carrier, it spins that shaft, makes the tractor go forward, makes the tractor go in reverse. When you start to provide steering, where you're spinning this steering motor counterclockwise or clockwise, now you're changing this outside ring gear, and that changes the ratio to how fast the left track goes and how fast the right track goes. So we slow down one track and speed up the other at the same rate. It keeps constant centerline speed for the operator, so whenever they're turning, they're going the same speed, and it keeps constant power to both tracks. So that's how we do diff steer. It's a long explanation, has nothing to do with electric drive, but it's important to the story. So with the XE, we're able to put a larger steering pump and motor on here where we get more power out of it, so we're able to get more power in a turn, carry more material around a corner, pry out a little bit better. If you're pioneering a road in the side of a hill out here in the driftless region of Iowa, you need that power to be able to pioneer that road out of the side of that hill, and that's what allows us to do that. So steering power is pretty good. A couple other things that we talked a little bit about the differences between the D6XE and the D7E. As I'd mentioned, switch reluctance instead of permanent magnet, smaller, more powerful, more efficient, uses less energy, has less waste. Okay, so big deal there. Also allowed us to simplify the cooling system. So on the D7E, we had to cool the generator. On the D6XE, we don't cool the generator. So imagine a system so efficient you don't have to cool it. Because the worst thing you can do is convert diesel fuel into heat and noise, right? So unless you're running that big 650 out there, that's fun to convert diesel fuel to heat and noise. But here we don't want to do that. We want to try to keep it as efficient as possible. And that's one of the things that allows us to do that. That switch reluctance doesn't make the heat that the previous system did. Would think steering around emissions. That I see where you went there, steering around emissions. I like that. So it's not a hybrid system. We define a hybrid machine as one that stores energy. So if we had an engine generator, stored energy in a battery, and then put it into the motor, then that would be considered a hybrid system. This isn't considered a hybrid system. Yep. You have emissions on everything anyway. Everything from, if that engine is 75 horsepower up to 750, you do need to have the emissions control, DEF in particular. Even below 75, they still have DPFs. And above 750s, they still have some controls as well, too. No, only if it was tethered. If it was tethered, you'd be carrying an extension cord with you back and forth on the job site. Then you wouldn't have to have emissions there. But let the power plant do that. So we talked about single motor instead of two. That was a nice improvement with the D6XE. The powertrain ECMs got less complicated. The whole engine got less complicated. We have less ECMs on the engine and more combined ECMs, which is great. Makes it easier to support. So longer stator life, no accessory system. One of the key things we did with the D6XE, we went back to the standard accessories. So instead of having a electrically powered water pump, we went with a belt-driven water pump and a belt-driven air conditioner compressor. One of the key reasons we did that was now this is the exact same engine as the D6, 336, 340, same engine, same parts, same components, same filters, same oil, same everything. So it didn't have unique components like the D7E did. That could always be a little bit of a challenge. Having unique parts in the parts system is always a challenge because the part you need is always in Melbourne. So unless you're in Melbourne, then it's if you're in Melbourne, the part's in East Peoria, Morton, So we also, to your point, improved the traction control system where he took off. This was his slide. We improved that traction control system quite a bit. There's so much torque in these electric drive systems, it's very, very easy to spin the tracks. That was one of the challenges we had with the D7E in some of the drier areas of the world. Think Colorado, Wyoming, New Mexico, where it's so dry out there, the dirt gets pretty hard. And so that traction control system wasn't good enough, so the ride was a little rough. So we really improved it with the D6XE and made it significantly better. So having a tractor that you can have an electric drive and a standard power shift is pretty important to us. So the D6 having the standard mechanical, the D6XE having the electrical, all of the rest of the tractor, the rest of the machine is basically the same. Same blades, same undercarriage, same rippers, same work tools on the back, same cabs. So very, very similar in terms of build on those machines. So we're able to support them really well. I mentioned that cooling system, so D6XE, same thing, separate circuit cooling system, where it's got that separate radiator in there, pump, hydraulic oil cooler, and we're still cooling the inverter and cooling the motor case back there as well. Each word. So safety, same thing on that. We want to make sure we're monitoring how much energy is in the system, letting the operator know if there's a problem. So if there's any sort of ground fault that's detected, immediately gets notified to the operator so they know what's going on. Before there's any hazardous voltage in the system, we're able to notify the operator and get that taken care of. So been pretty darn robust over the years. All right. What else do we have going in the electric world, right? I'm sure some of you came in here thinking that I was going to talk about batteries and bulldozers that you have to plug in overnight and plug in at lunch. We don't have those yet. We don't have those yet. Yeah, solar-powered, little solar panel on top. Nope, we don't have those yet. We do have a few XE-style machines and a few battery electric machines that are in the portfolio as well. So we'll start off with this guy here. This is that R1700XE. And this is a battery electric underground mining loader. So kind of came from the old Elphinstone days, but it's a fully battery electric underground mining loader. They would call these an LHD, load haul dump. Basically would go in underground mine, scoop up, go over to the dump area, and dump. So very short machines, kind of like taking a wheel loader, taking the cab off, putting it on the side, right? But very, very specific. This is a full battery electric machine, so it does have batteries in the back. We had to develop our own charging system to be able to charge those batteries down in those mines. A lot of those machines go underground and they never come back. So a very unique setup right there. So what's the value of a battery electric and zero emissions underground? Air, yeah. Think of the air, think of what you have to do to get that air out of there in an underground setting. How many millions of dollars of air handling equipment do you have to buy to do that? That's why this is a really, really good solution for underground. So we've had it out a couple years now, and I think you're doing pretty good with it. So D11XE, this is the next dozer that's been launched in the XE lineup. So they had it at 2021 Mine Expo, and then they had it at the Mine Expo, the most recent one, which I guess would have been 24. So it is a wheel station, kind of like what we talked about before. We have one motor in each wheel station, left and right. So it's a little different than the D6XE, where we use that propulsion module and differential steering. These have always been clutch brake tractors. Even today, the D11 and the D10 are clutch brake tractors, right? So electronically controlled, but you're pulling a clutch, taking all the power away, and using a brake to steer that tractor with fingertip control. So it was a pretty easy design to move that. I shouldn't say that over to electric drive. So it's pretty similar in terms of operation. Folks really like that. So that's the next electric drive dozer that's out there. And then there's a handful of battery electric machines that we've been launching over the last few years. 301.9, nice little mini excavator. I could see some applications for that if you're doing demolition inside of a building. Yeah, you don't need to have that emissions and exhaust and that extra air handling equipment. Take that little battery electric in with a hammer on it, peck away at those columns until they come down, push that stuff out of the way, elevator chute, you're demolishing a building from the inside out. So, and then of course, 950 battery electric, 320 battery electric. A lot of our European counterparts are getting a lot of demand for these type of machines. So that's where a lot of those machines are right now, is over in Northern Europe. So a lot of demand and interest over in there. All right. End of prepared comments. Any questions? Sir. On these little guys, gauge that shows the battery voltage? On the D6XE? Nope. We don't monitor battery voltage or anything like that. Again, it's with the energy generator into the inverter and immediately into the motor. So we don't store any energy to speak of. There's a little bit in the inverter, but it's a few seconds worth of energy. So we don't really store any energy. Yep. Sir. Mm-hmm. Yep. Yeah. So the amount, since it's all solid state electronics, there's not a lot of heat generated in the inverter. So, being able to convert that energy over, we're able to do it really, really high efficiency levels, not really generate a lot of heat. Again, that's the second coolest thing in the system. So it's not really generating a lot of heat that it needs that much cooling in there. But, anywhere, I'd say diesel power shift versus diesel electric, 20% better fuel efficiency. So we're just simply not making that much more heat that we have to then take energy and blow out of the system with the fans. Yeah, so just full idle, both engines are going to be spinning about 800 RPM or so. The real key with idle and throttle control is with the XE, we want the tractor to run at 1400 RPM. So even if you spin the throttle dial all the way up, it's not going to go to 1800, 2000, 2200. It goes to 1400. All right. If anybody listened in to the gentleman talk about turbochargers this morning, what did he say the magic RPM was with full lug and full torque? 1400 RPM, right? So we want to live at 1400 RPM. It's fast enough to get maximum torque, but yet it's slow enough that you don't have extra parasitic loads through the engine. So when you load that tractor up and you exceed the requirement for what it can make at 1400, then it will lug up into the load. So we will idle up to around 1700, 1750 when you need it. And as soon as you don't need that power anymore, we're going back down to 1400. So we want it to live at 1400. That's where a lot of that efficiency is just simply keeping that engine RPM down at that 1400 level so you have enough torque to do the work, but you don't have so much that you're wasting energy. Yep. Nathan.
So a couple months ago, I was listening to a podcast, and there was a cat guy talking about it, and he was talking about the definition of the V8.
Mm-hmm. Was he handsome? Yeah.
60, 65, 70, 75, and then he dropped this 80 model, and then the V8. So I'm just curious, is there some collectible model that none of us know about? And the 80, or is that like a 8E plan on maybe?
I am sure. So I went walking around the back of the Earth Moving Legacy Center, and there was a lot of stuff back there. I'm pretty sure that one of those is an 80. I'm pretty sure. That doesn't get you a hat, Nathan. Yeah, you should. Any other questions? Yes. D6, take rate between power shift and electric, as many as we can make. Electric. It's about 1/3 electric and 2/3 power shift. We've been sold out since 2019. So, very, very popular tractor. Yep. Starter is just a regular 24-volt starter, no change. Nothing to do with the electric. Regular old starter, regular old batteries. Yep. That was one of the key things with that getting away from the specialized components of the D70. We wanted to get back to standard starter, standard engine, standard everything. So, yep. Standard alternator, standard air conditioner. One of the smarter things that we did. So, cool. Any other questions? Good stuff. All right. Well, thanks, everybody. Thanks for sticking in with me. It's not even air conditioned in here, and you guys stuck around. Thanks a lot.